Hi guys, and welcome to this week's presentation. We are going to do a talk about the nuclear bomb, and hopefully we're just going to gain a basic understanding of how these weapons work, what kind of damage they can cause, what the radiation's like, all that kind of fun stuff. So we're going to go ahead and move forward. What is a nuke? A nuclear bomb is a weapon of mass destruction utilizing nuclear energy via nuclear fission to create large amounts of damage very quickly. There are two very significant types of bombs that we use today. They are the atomic bomb and the hydrogen bomb. First thing I want everybody to understand, there's two concepts that you have to have a grasp on before talking about the two different types. Alright, so that basic understanding that I was talking about is we need to understand power and radiation before we start digging into the two different types of the bombs. Okay, so power, it's the measure of energy produced by any sort of nuclear explosion. It's measured in the TNT equivalents of kilotons and megatons. And that's just basically the overall strength, magnitude of the explosion and the energy produced. Radiation comes in three different forms from a nuclear explosion or nuclear detonation. You'll have alpha, beta, and gamma rays. Alpha rays are not very harmful to us. More so, you can be protected from alpha radiation just by having your normal clothing on. Beta radiation, a little bit more dangerous, can cause a radiation burn on your skin from anywhere to 7 to 10 meters from ground zero, but overall not the most concerning form of radiation, and especially not with long-term effects. Gamma radiation, however, is definitely the most dangerous. The only protection from gamma radiation is lead and concrete barriers, and the most known effects from gamma radiation include the radiation sickness, cancers, and gene mutations. Now, the gene mutations and cancer you may not see right out of the gate, more so long-term effects, but those effects are still definitely felt from any sort of nuclear explosion. So moving forward, we're going to talk about the atomic bomb first, otherwise known as the atom bomb. All right. And the atomic bomb, generally, just like the picture that I just showed, elongated rounded torpedo shape, and the main components of an atomic bomb is uranium-235. Now there are isotopes, uranium-234 and 236, that are actually not usable to us for when creating this type of weapon. Uranium-235 is refined again and again so that we can eventually create the most power and try and get the most bang for our buck. But sometimes that process goes wrong and plutonium-239 is created, and that's just kind of like a fallback that can still be used to create a weapon. However, it's not going to give us the most bang for our buck. Then we move forward looking in how these bombs detonate. We go ahead and the idea is to get the inside components to critical mass. And if you only have one critical mass value, that's not enough to create the most effect. So we need anywhere from 4 to 5 critical mass levels so that we get the most amount of destruction from the weapon. So, like I was just talking about, critical mass is important for this bomb to detonate. However, we need to be able to get the components to critical mass. So instead of thinking about the torpedo shape like I showed you, that's the normal shape of the bomb in physical world. However, if we take a step back and we think about it in a spherical shape for a moment, if we take the bomb and make it into a sphere, and then we coat the outside of the sphere with an explosive material, we have to then detonate the explosive material before impact. Then that explosion creates the pressure change from outside to inside, causing the insides to shrink and get down to that critical mass levels, then allowing the nuclear reaction to take place. We move ahead to the hydrogen bomb. Hydrogen bombs are a little bit different. They work off of thermonuclear fission, which is basically just a fast explosive type reaction that takes place inside of a charge. And the hydrogen bomb is aided along by elements like deuterium and tritium, and the main ingredient for this bomb is actually lithium hydride. So detonation occurs via integrated nuclear devices, and the short version of it is basically there's a small low power explosion that happens in the head of the missile, which then creates the chain reaction down through the rest and goes ahead and creates that nuclear explosion. Biggest take home message with the hydrogen type bombs is that there's no theoretical limit to the amount of power, since you can kind of compact everything down and create the reaction from one small explosion inside of it, and then the detonation portion is much bigger. So we'll kind of talk about a little bit about that in the next slide. But it makes these types of bombs very dangerous, because if they fall into the wrong hands, there's no telling how big they can create the explosion and how big the energy release is going to be and how much radiation is going to be released. Very unpredictable. So moving on to some of the examples. Up on the top left is the atomic bomb Little Boy that we used in World War II on Hiroshima in 1945. Produced anywhere from 13 to 18 kilotons worth of energy. Fat Man 3 days later on Nagasaki produced about 21 kilotons, which is obviously enough to completely level the cities. Everybody's seen those pictures where there's just nothing left in the blast radius, and then the radiation sickness therefore after killed so many people. And then down on the bottom is the Tsar Bomba, and that was a hydrogen type bomb which created a 58.6 megaton explosion and energy release, which is very high, much more than any of the atomic bombs that we've used so far. And then just to kind of wrap everything up, I wanted to kind of just share some information about world power as far as nukes go. So there are approximately 15,000 nuclear warheads across 9 countries throughout the world. And if we were to say go ahead and combine all 15,000 of those, with each one having a 500 kiloton explosion capacity, we end up with a super bomb that's about 7,500 megatons. Yes, that's so much more energy than any of the bombs that we've dropped before. However, people worry about like a nuclear holocaust if we just start kind of throwing these nukes everywhere. However, all of that energy is not enough to go ahead and wipe out the civilization on Earth. So no, we don't have to be worried about that right now. We don't have to worry about an imminent nuclear strike that'll wipe out everybody off the face of the planet. But again, just to touch back, that's the hydrogen bomb doesn't really have a set number that is its max. So that's the one thing that makes them a little bit more dangerous. Thanks for watching, and I hope you guys learned a little bit about something about these nuclear weapons. Thanks.